So, dear students, very good morning. See, as you know, in trigonometry, introduction to trigonometry, type 2 example continues today in lecture number 7. In lecture number 6, if you know and remember, we have taken the examples of simply making the table and examples of evaluation. Now, in today's lecture, my target is to just explain you the verification example. In exam, they ask prove that examples, that is the examples of verification. From your work paper 2, we are today targeting this particular example number 15 first. I have already written it for you. You also write and you see from your work paper 2 itself. Just verify. First, what we need to target is we need to target LHS first. Every time I will prove LHS here and RHS there. LHS cos 60. Here you just have to put the value 1 upon 2, result number 1. Then let us go for RHS. In this lecture, my target is just to take only one type of examples. Understand as per the work paper. And that is only 4 example I am going to just take. Those 4 examples of simply evaluation that we are going to target. 1 minus, you see from the table, what is the value of tan 30? You see from the table it is 1 upon root 3. Here it is square, so we will write 1 upon root 3 whole square upon 1 plus 1 upon root 3 whole square equals to 1 minus 1 upon root 3 square means 1 upon 3, 1 plus 1 upon root 3 square 1 upon 3. After just writing this, just simplify. If you take LCM in numerator, 3 1 ja 3 minus 1, 2 upon 3. Here you take LCM, 3 1 ja 3 plus 1, 4 upon 3. This is cancelled. So you got 2 upon 4. Simply cancel 1 upon 2. This is your result number 2. You got LHS and RHS both correct. So at the end you just have to write therefore from result 1 and 2. What you got? LHS equal to RHS. Okay, just you verify before I take the next example. Just verify. You have to prove LHS and RHS both to be equal. Understood? Just check this. Simple example, not so complicated. You can prove LHS equal to RHS very easily. Understood? Right? You verified the example. Okay, let us take the next example of verification. The next one. See from your work paper 2, we are now targeting example number 17. First I am writing it here. prove that cos 30 equals to, what is given there, sin 60 plus cos 30 upon 1 plus sin 30 plus cos 60. I have taken little difficult example. First you just write this example. It is already given in your work paper 2 under the section verify, example number 17. Okay, first LHS. LHS so simple, so first let us take RHS. First you write the expression sin 60 plus cos 30 upon 1 plus sin 30 plus cos 60. After writing RHS, just check the value from the table. Sin 60 root 3 upon 2, cos 30 root 3 upon 2, 1 plus sin 30 1 upon 2, cos 60 1 upon 2. First you have to substitute, very important, the correct value. Then and then you can verify LHS and RHS. Correct value substitution is very important. Understand? Now you take the LCM. Here you see root 3 common LCM, so 2 root 3 upon 2 upon, just verify this 1, this half plus half 1, 1 plus 1 that is 2. Here 2 got cancelled, so you got root 3 upon 2. This is your result number 2 which we have taken first. So this is result number 2. Now result number 1, so you know very well, LHS. That's equal to cos 30. What is the value of cos 30? Root 3 upon 2, result number 1. So simply you got both the result. You can write from result 1 and 2, LHS equal to RHS. It is verified. Understand, from result 1 and 2, LHS equal to RHS. Look at the sum, because we want to take 4 examples of prove that. Understand? 2 examples of prove that we have done. We want to target only 4 examples. Understand? Of prove that. Right? First you have a look at this, right? Then let us target few more 2 examples of this type, where they are examples simply of only prove that. Understand? We are targeting now example number 18. What is the example if A equal to 30 and B equal to 60? It is given. Then verify that sin A plus B equals to sin A into cos B plus cos A into sine b. This is the example. First, you need to understand this example very properly. You read it twice because this particular example which I have written here, actually this example hasn't been anywhere in your NCERT textbook. But this example was a part of the old textbook and also it appeared in few reference books. So, if in board, if they ask this example, understand you can't nullify the fact that the example is looking out of the textbook. Not at all. They can ask such examples. Actually, this is what you are going to prove. This one is a particular identity formula which you are going to learn, and you have to remember sin A plus B, sin A cos B plus cos A sin B. When you go in 11 science, you will come across the same formula in 11 science. So this particular identity which I have written here is also important. Understand, for you to remember it, because it is very important identity when you go in 11th standard and learn trigonometry. Sin A plus B, there it is sin alpha plus beta, sin alpha cos beta plus cos alpha sin beta. You are already given value of A and B. So first LHS. First, let us write LHS. Concentrate here, every student. Sin A plus B. Just substitute the value. Sin, થોડું ધ્યાન આપવાનું આ ચેપ્ટરમાં, તો તમને ઇઝી પડશે. 30 plus 60. That's equal to sin 30 plus 60, that is 90. And what is the value of sin 90 from the value table? 1. So result number 1 you have got. LHS equal to 1 we obtained. Now let us go for RHS, okay? RHS equal to, first let us write sin A into cos B plus cos A into sin B, okay? First you write this expression sin A into cos B plus cos A into sin B. Now let us substitute the value. In place of A, substitute 30. In place of B, substitute 60. Sin 30 into cos 60 plus cos 30 into sin 60. After substituting the values, now you have to look their values from the table you already have. Just look at the table. What is the value of sin 30? 1 upon 2. What is the value of cos 60? 1 upon 2. What is value of cos 30? Root 3 upon 2. What is the value of sin 60? Root 3 upon 2. No cancellation. Numerator to numerator multiplication. 1 1 ja 1, 2 2 ja 4. Root 3 into root 3. શું થાય મિત? 3 upon 4. common LCM 1 plus 3 upon 4, you got 4 upon 4, cancel 1, that's result number 2. And at last you just have to write the statement. What is that? From results 1 and 2, LHS equal to RHS. This is actually an identity. Understand? This particular identity which you have wrought stands correct for all values of A and B. If you take A 20, B 70, which is still not a part, but if you apply here, you will get the same answer. So this particular identity appears correct for any values of A and B. See how they can design the MCQ in exam. Suppose you all know section A, either true false, fill in the blanks, MCQ or one line. Suppose in that particular section you are asked this way. Suppose I am writing. Suppose you are asked this way. Sine alpha plus beta equal to this. Fill in the blanks. They can ask such fill in the blanks in trigonometry. So what you will write? Sine alpha plus beta equal to sine alpha into cos beta plus cos alpha into sine beta. This way they can design the MCQs in board exam. So when you just this particular identity hasn't been mentioned in your textbook, but you need to remember this. Understand, sine A plus B equal to sine A into cos B plus cos A into sine B. You have to remember this. Understand? Right? So this is one more example. Now let us take the last one in this lecture, because in this lecture my target is to only take verification example or prove that example. That is our target. Now let us take number 20. This example is needs more attention. If theta equal to 30, then you have to verify two facts here. First, sine 3 theta equal to, what is given? 3 sine theta minus 4 sine cube theta. And at the same time, second also, sine theta equals to under root 1 minus cos 2 theta upon 2. Two results you have to verify in this particular example. Two results. Understand? First, we are targeting the first. Theta equal to 30 degree, that is given, and you have to verify two aspects, two results. So let us target the first one. What is first one? What we have to prove? Sine 3 theta equal to 3 sine theta minus 4 sine cube theta. Okay, this is what we have to prove. First you write LHS, that is sine 3 theta. Sine, be conscious here, 3 into what is the value of theta? See, value of theta is 30, that I am substituting here. Now this is sine 330 is 90. What is the value of sine 90? 1. So you got result number 1. Okay. Now after getting result number 1, let us target first RHS 3 sin theta minus 4 sin cube theta. LHS you already got. Now you are targeting to get RHS, that also should come equal to this. So 3 into sine theta, what is the value of theta? 30, minus 4 sine cube 30. Substitute the values. 3 into sine 30, that is 1 upon 2, minus 4 into sine cube 30, 1 upon 2 whole cube. This is equal to 3 1 ja 3 upon 2 minus 4 into 1 upon 8. Cancel it. So we got 3 upon 2 minus 1 upon 2. Now the common LCM, 3 minus 1 upon 2, 2 upon 2, that is 1. Result number 2. Then before I start the second, you can make a statement that from results 1 and 2, LHS equals to RHS. Okay. Just you see here, you don't make any mistake. 3 theta means substitution has to be in this way. Okay, so is it clear? Right. Now see, let us take the second option also. The first option has been proved. Now the second option, again LHS, we are taking the second option. LHS equal to sine theta, that sine 30 equals to 1 upon 2. Result number 1, RHS equal to under root 1 minus cos 2 theta upon 2. Here be very conscious. 1 minus cos, see here, 2 into value of theta, that is 30 upon 2. Now this is under root, just see it now. This is 1 minus cos 230 is 60 upon 2. Let me continue here. Under root 1 minus cos 60, that is 1 upon 2 upon 2. If you just 1 minus half means half upon 2. Here 2 as per rule will multiply with denominator. Take the square root 1 upon 2. Result number 2. Then you just write. See the simplification and you write from results 1 and 2, LHS equal to RHS. Understood? Here you need to be very conscious when you substitute this value, and accordingly you have to simplify. Here also 1 minus half, half, 2. This will multiply here 1 upon 4, 1 upon 2. Okay. So dear student, as far as type 2 is concerned, like in type 1, we have allocated 5 lectures. As far as type 2 is concerned, we want to allocate 3 lectures. Type 1 was little lengthy. Type 2 so just based on the value table. So 3 lectures. Lecture number 6 only evaluation. Lecture number 7 only verification, and then lecture number 8 will be the rest of the example in type 2. So type 2 we are going to complete just in 3 lectures. Okay, right? So what will be today's homework? Very simple. In what is lecture 7 homework? You have to just see the WP2. Like in lecture number 6 I give you to do all example of evaluation. Now you have to do all examples of verification. That is your homework for lecture number 7. All example of verification to be proved neatly. Okay. So with this we are completing lecture number 7. Homework needs to be time to time again for verification. Understand? And as we have started lecture number 13, chapter number 13 and examples of trigonometry also. So I am sending the test schedule. Understand, tomorrow. The test schedule, just you look at that and accordingly let us start taking the test. Okay. As usual, time 8 to 9. Thank you very much.